Hi, welcome. In this video, we'll solve problem movie marathon on abstract binary search. Let's check out this problem statement. So before starting the problem, I want you all to go through the problem statement, understand the little bit sample input and output, and then we can start. So Mike is organizing a movie marathon for his friends. So movie marathon is like in marathon we run for 26 miles, right? 26.2 some miles. Similarly, in movie marathons, we watch movie for 26 hours. So it's so watching movie for these many hours. So each week, so he has n movies. So I guess this is an n movies to choose from, each with a duration in minutes given in an array. So this is our array. He wants to include as many as movies possible, but he needs to keep the average duration of these selected movies less than k. So that's an important line, like average duration should be less than k of selected movies. So the marathon doesn't run too long. Given q different time limits of k, for each time limit, help Mike select a subset S of movies such that the average duration is less than the k minutes. Okay, maximizing the number of movies included. So we need to maximize as well. And for each k, print maximum number of movies Mike can include in his marathon. Okay, so let's understand it. Let's understand it in a more bit clear way. So what I will do, I will just bring this sample input and output in the next page. So here we have n is equal to 5. So n equals to 5 and we have an array. So I will say that I have an array of 1, 2, 3, 4, 5. Okay. So these are basically time limits, like in minutes I have this. So this is time of a like movie. Let's suppose time of a movie. And we have this key queries. So I will say I have q5 and inside this queue I have k minutes. Like, so what I need to do, I need to select a subset. Okay, a subset, right? So basically I can select any numbers. Suppose one, this is one subset, 1, 2 subset, something like this, such that this average of that subset, if it is S, the average of subset S should be less than K. And as well as this subset average of S should less than K, and it should have the maximum time, like maximum time or maximum elements you can say. Okay. So let me show you how this 0, 1, 2, 4, 5 is coming. So basically, let's start with the first query. Okay, so I have k equals to 1. Okay, k equals to 1. I want to select a subset whose average will be less than k. Okay, so here in this array, you can see, even if I am selecting the first lowest element, right? Okay, this element, what will be the average? The average will be 1 only, right? And that is not less than k, not less than k. So the answer is 0. Like we can't select any subset whose average will be less than k. Now let's check for k is equal to 2. So if k is equals to 2, so I can select this as in subset. Okay. What is the average? Average is 1. Let me write it clearly. Average is less than 1. That is k. We can also select 1 and 2 elements. Okay. 1 and 2. And the average will be 1.5, right? 2 plus 1, 3 by 2, that is 1.5. That is also less than k because k is here 2. Okay. If I am selecting 1, 2 and 3, what will be the average now? So here the average will be 6 by 3, that will be 2. That is not less than. Okay. That is not less than k. Okay. So here we can't select these three elements, right? Okay, because the average is not less than k. Now we need to choose from these two. But here, like in the problem statement is mentioned that what we need to do, we need to find the maximum number of movies, right? Maximum number of movies. So basically here we are getting only one movie, here we are getting two movies, right? And still the average is less than k, 1.5 is less than k. So I will select this as an answer, two movies, and that's why the answer is 2. Okay, now let's see one another example, or with a different k equals to 3. So let me put it in the next slide. So here, suppose if k is equals to 3, okay, and in the array we have 1, 2, 3, 4, 5, okay. Now I need to select the subset. So what are the possible subset that are less than k? Okay, so 1, average is 1, which is less than k. Then I have a subset of 1, 2, that average is 1.5, less than k. So let me write the average as well. 1 less than k, then average 1.5 less than k. Then here we have an average of 1 comma 2 comma 3, that is an average of 2, that is less than k. Okay, then we have 1 comma 2 comma 3 comma 4. What will be the average? That is 2.5, and that is also less than k. If I am going a bit higher, 1, 2, 3, 4, 5, selecting this subset, what will be the average now? That is 3, and which is not less than k. Okay, okay. So here we have these many subsets that are less than, okay, but we need to select the subset that has a maximum number of movies. So here I am getting maximum number of movies, 4 movies. That's why the answer is 4. Similarly, if I check for k is equal to 4, okay, so here we are getting 3, okay, and this is the largest subset I can find in the array, right? 1, 2, 3, 4, 5. So in this larger subset, I am getting 5, like the average is 3, which is less than 4. Okay, so the answer will be 5. And for 5, again, this is the only largest subset possible. So that's why the answer is 5. Okay, 5 are the maximum movies a person can watch, because these are the movies provided. So I hope you are clear with this problem statement. Now let's understand how we will solve this problem statement. So what is our goal here? I write what we need to plan for the goal is, I want a subset, okay, with maximum number of movies that has an average less than k. Okay, this is my goal. A subset with maximum number of movies that is an average less than k. Okay. So how we will calculate the average? Basically, it is sum divided by number of movies, and right, this is what average is. Okay. Now, if I want this average to be less so that I can get the k number of movies, but I want maximum number of movies. So what I can do, I should increase the number of movies, but I should take the sum as low as possible. Lower sum, right? This value should be low so that the average should be less than k. So low sum movies, basically how I will get low sum? When I select a movies with small duration. So here you can see, here that's why we are selecting 1, 1, 2, because these are movies are with small durations, right? And then for higher average, like when k is 3, 4, 5, then we are simply adding movies with higher minutes. So whenever we are taking some, we should take some from low time movies or small duration to high duration. So don't you think that there is a need of sorting? that you need to sort the array, because here it is already sorted. Okay, here the array is already sorted, but suppose the same pattern, same array is given in this form. Suppose you have an array of 4, 5, then 2, 3, then 1. So if this is an array, still my subset will be same, right? Because subset cannot be continuous. Okay, this is not a subarray, subset. So basically subset, okay, not necessarily continuous. Needs to be continuous. Okay. Relative order may not maintain. May or may not maintain. हो भी सकता है और नहीं भी. May not maintain. Okay. So that's by the observation we are getting that there is a need of sorting, and here the array is already sorted. Okay. So now let's come to the next slide and let me quickly create an array. So we have an array of this size. So let me put 1, 2, 3, 4, 5, and these are the indexes 0, 1, 2, 3, 4. Okay. Now what we need to sort it, and this is already sorted. So suppose we have sorted the array and we have this as a result. Now basically what we need to do, we need to find, again the goal is we need to find something average that should be less than k. Okay, so we need to find the relevant average, right? And from that average we will get the maximum number of movies. Okay, so what I will do, instead of taking, because the here the array is not value to me because I want an average. I always play here between average, like 1 is less than k, 1.5 is less than k, 2 or 2.5 is less than k. So the most important thing for me, it's an average. So what I will do, I will take the average of this array. So now the average of this array, suppose I have only one element, so the average will only be 1. If I am taking these two elements, 1 plus 2, the average will be 1.5. If I am taking these three elements, what will be the average? 2. 4 elements, 2.5, and 5 elements, it will be 3. Now this is making some sense to me. Right? This is an average array. Okay. So now I can quickly check that is my average is less than k or not. Okay. So now you have k. Suppose you have q queries basically, and k can be 1, then 2, then 3 up to whatever the number present. Okay. And you just need to figure out. So you just need to figure out an average that is less than k. Okay. And now this is sorted. So average that is less than k and with maximum number of movies. So can you guess a sense? Like here is a sense of upper bound. Something as upper bound we can include, right? So if you are not aware of this concept upper bound, so in binary search, we have a concept of lower bound and upper bound. Okay, so basically suppose here if k is equals to 2, so and there are different elements, so suppose 1 1, then 2 2 2 2, then 3, then 4, then 7, something like this. Suppose you have an array something like this, and inside this array, okay, so the here is the 2, right? But I want to find a lower bound of it. That means I am more interested in the number that is lower. Okay, that 2, that is the first 2. Okay, if I want to find the upper bound of it, so I am more interested in the the 2 that is at the last. Okay, last occurrence of 2, first occurrence. So this is for first occurrence, this is for last occurrence. Okay, similarly the same case is here, k with, suppose if k is 2, right? So you need to find a number that is less than k, but you need to find the upper bound of it. That means 1.5. Suppose k is 3. Okay, so you need to find number that is less than k. All these numbers 1, 1.5, 2, 2.5 are less than k, but you need to find an upper bound of it. That means 2.5. So here we are getting a sense of upper bound, and that's why I'm concluding that we can apply a binary search here. So this is how you are getting an intuition of how you can apply a binary search here. So here we can simply apply a binary search. We can find is like a starting point, ending point, and by which we can simply conclude the. Let's quickly check out like how we will apply the binary search. So let me take this to the next page. So now let's check. So this is our average array, and everything like the work we will do on average array only. So suppose let's solve for one of the problem statement. So for k equals to 3, we were getting an answer of 4. Let's quickly see how we will get an answer of 4 by applying binary search. So here k is equals to 3 and answer is 4. And it should be 4, right? Because a subset which is less than k, like less than 3, the average is less than 3, it's 2.5 and having the maximum elements. So in 2.5, how many movies I am adding it? 1 plus 2 plus 3 plus 4, right? All these movies, right? 4 movies. Okay, so that's why the answer is 4. So now let's see. So what I will do, I will take one S. Okay, and in the initial, let's put initial point as S is equal to 0 and is equal to, that is average array length minus 1. Okay, dot length minus 1. So I will say that will be 4. Okay, so we are starting with 0. We have 4. We will take one mid value. Okay, mid value, and then we will calculate our answer here. So if I am starting with 0 and 4, what will be the our mid value? 0 plus 4 by 2. Okay, so let me put the formula here. S plus E by 2. Okay, and you can also, like, if you are like, because in this is not possible in Java, because if S and E have very high values, so you can simply do something like S plus E minus S by 2. So now here, so let's calculate the mid first. Okay, let's add the values one by one. So 0 plus 4 by 2, I will get the mid 2, S plus E by 2 basically. So now the mid is 2. So this is my mid. Let me remove all these things. So my mid is this. Let me denote with simple M. And this is S and this is E. Now once this is mid, what I will do, I will check the conditions. So there will be hardly 2 conditions. Okay. So one condition is your average array mid can be less than k. Okay, and your average array mid can be greater than or equals to k. Okay, so if it is less than k, what you supposed to do? If it is less than k, that means you got an answer. Okay, this is what we want. We want something average should be less than k, but still we need to move for higher answers, right, with maximum number of movies. So what I will do, I will store the answer. Okay, but I will search for the other one. So I will say is is equal to mid plus 1. Okay, but if it is greater than equals to k, that is not our answer. So we don't, what do you need to store it? We will simply say and is equal to mid minus 1, like lower the value. Okay, so now let's see. 0 plus 4, the mid is 2, and, and so here k is 3. Is my average of mid is less than k? So yes, it is less than k, right? That is 2. So what I will do, I will store the answer, but I will move for the newer ones. So mid plus 1, what will be my answer? S now, S will be 3 and will be 4. Okay. So now my S is here, something like. Now I will again check out the mid, new value mid. So 4 plus 3, that is 7 by 2. And 7 by 2 will be 3.5, that is floor value will be 3. Okay. Mid is equal to S plus E, that is a floor value. Okay. So here it is 3. And now let's again check what is average mid. So average of mid is 2.5, which is again less than K, right? That's a good thing, right? Which is, so what I will do, I will store in the answer that is 2.5. Okay. And I will again search for the mid plus 1. So now let's do mid plus 1. 4, 4. What will be my mid? Again 4. What is the average? That is 3. Right? The average is 3. So that is not our answer. So we will do n is equal to mid minus 1. So now end will be this. S is still 4. And here we are stopping the condition because S is now greater than n. Okay. The S and E basically are starting and ending point. If you are getting confused, S and E are my 2 pointers, starting and ending conditions. So 4 is greater than 3. So we will stop it here. And here we are getting the maximum average, that is 2.5 here. So on maximum average, on this average, okay, on 2.5 average, that is less than K, that is 3, how many movies we are getting? So how we can easily conclude these movies? We will basically select the index. So for on 2.5, we have a 3 index, okay, and 3 plus 1 is the number of movies. So here you can see, like here it is starting for 0. That's why I am doing 0 plus 1. So here there is only one movie. So 0 plus 1. Here we have two movies. So 1.5. Here we have three movies. So that's why the average is 2. Here we have four movies. Okay, you can see four movies. One movie only, two movies only, three movies. Okay, so this is how we will get the answer. So I hope you got the understanding of this whole approach. What is the process? How we will use binary search? How sorting can help us? So now we are good to move for the code part. Let's quickly start the code.